logarithmic and exponential equations. Solving exponential equations algebraically. Each side cannot be written in the same base. So if they can be written in the same base, then you do that. If they can't, then you have to turn to a log, okay? So in this case, this one can be written as a common base. I can go 9, it's 3 squared, x plus 1 equals 3 cubed. Make sure to distribute the 2 in, so I get 3 to the 2x plus 2 equals 3 to the 3, and then 2x plus 2 equals 3, 2x equals 1, x equals a half. And I can do that one with common base. However, if I didn't spot common base, or they chose to, instead of solving it common base, they chose to change it to a log, you can do that. You can convert it to a log if only one of the bases has an exponent. If both bases have an exponent, we're going to have to do a separate thing. We're going to have to log both sides, which we're going to do today as well. So in this case, one of the bases has an exponent, so we can convert it to a log and solve. That's the reason why we do logs with exponents. Remember, if you have a log and you want to solve it and you're missing the x beside the log or the x in the base, you change it to exponential and solve, right? So exponential, if you're missing this x up here and you can't do common base, you're going to change it to a log and solve. You just switch them back and forth. So how do we convert to a log? The base of the exponent becomes the base of the log. Whatever's over here gets put beside it, and it always equals the exponent. Now I want to get x by itself, so I'm going to minus 1. So I'm going to get log base 9 of 27 minus 1 equals x. Do not say log base 9 of 26. Do not minus that 1 from that 27. These are attached and stuck together. The minus 1's at the back. So we're going to put these together. If you don't have the log base button where you can't go math and then pick log base from the bottom, you're going to go log 27 divided by log 9, hit enter, minus 1. So do that in your calculator. Log 27 divided by log 9, enter, minus 1. You can just follow along. So what did you get when you punch it in? A half. So this just proves that you can find the log of it and solve it. So often people will do common base first, okay? If you can do common base because it's often easier. This one, we can't find the common base between 4 and 12. There's nothing I can make them both be the base of. Some people will say 2. They'll say 2 squared, and then this is like 6 times 2. No, it has to be 2 to the something, right? Both of them can't be. So I've changed it to a log. The base of my exponent becomes the base of my log. This goes with it, and it always equals the exponent. So this one's really easy, because you literally just type it in. Log 12 divided by log 4. Okay. What's log 12 divided by log 4? Anyone? Bueller? 147. 1 decimal. Oh my gosh. 1.7924 blah 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 blah. Okay, so we'll go 1.8. If it's the diploma and it's numeric response, they'll always give you a rounding rule. Okay, the only way we can convert from exponential to log, is if one of them has an exponent and it's something equals something to the exponent, right? We can't have this little a value in front. How do we get rid of this? Do not put these two together. Do not be that cannot be the answer. You cannot times these two. The t is to just this, right? So what do I have to do? Bless you. I can get rid of this baby. And this baby's multiplied by that baby. So what am I going to do? Divide. So the very first thing you have to do is divide that over, or you can't change it to a log. So I have 11 over 19.2 equals 0.91 to the t. And now I can change it to a log. So the base of my exponent becomes the base of my log. So log 0.91. What's with it doesn't stay with it, so this is going to be with it now. 11 over 19.2, and it always equals the exponent, t. So now we can plug it into our calculator. We're going to get log 11 divided by 19.2 divided by log 0.91. If you don't have the base button. If you have the base button, you can just plug it in. If you have the fancy calculator, the exponent pops up, you can do math, and then you can arrow up to log base, and you can just punch the numbers right in. So if you have the fancy calculators, if you go math and arrow up, there's a button that says log base. When you press that, it gives you a little space to put in the base, and it gives you a little space to put in the number, and you just fill it in, and you're done. What answer did we get here? T equals? Anyone? Euler? Thank you. You try C. Okay. Divide by 150, and you get 200 equals 1.4 to the x. Change it to a log. Log base 1.4 of 2 equals x. And what do we get for an answer? 0.06. I feel like there's a lot of answer. Oh. 2.1. 2.1. 2.1 rounded. Final answer. Okay. Now, as we know, life changes because if we have two bases with two exponents, we can't convert it to a log. Bear with me, follow through. This is a lot of bit of writing. A lot of bit. Yes, a lot of bit. I'm really good at English. Okay. So when we have 5 to the 3x and 3 to the 2x minus 1, we cannot convert this to a log because there's two exponents, right? You set it equal to the exponent when you convert to a log. Which one do you set it equal to? I don't know. So you can't convert to a log. So the first step, what you do when you're trying to solve these ones, is you could y1, y2 them and get it with your calculator, find out where they intersect. But if it says algebraically, that is not going to work. So what we do is we just log both sides. Remember, what you do to one side, as long as you do to one side what you do to the other side, it's fine. Like I can multiply this side of the equation by 2 as long as I multiply this side of the equation by 2, right? It doesn't change the equation. So if I log both sides, it works. So I'm going to go log 5 to the 3x equals log 3 to the 2x minus 1. Okay, so this is where people blank and don't know how to do the answers. Even though I tell them you have to remember how to do this on a test, it's like they just, if it's a written response, they just leave it blank for life. So let's not be those people. So what we're going to do is we can use the power rule. We can take the exponents and we can drop them in front. So that's what we're going to do. We log both sides, then we take this lovely exponent, we drop it in front. Apply the law wherever you have powers, products, or quotients. So we're going to go 3x log 5. And I always put this in brackets. Now 3x doesn't really matter because 3x is just one term. But if it's two terms, you're going to distribute them in. So it's going to equal 2x minus 1, we drop in front, in brackets, log 3. This is why I write this in brackets. The reason why I write this in brackets is because you're going to distribute it into the log 3. If you forget the brackets, you're going to tell me this is 2x minus log 3. Everyone does it. That is not correct. That answer will be there. It is not good. Do not be that person. Write in brackets. So 3x log 5 stays 3x log 5. See, distribute where the exponent is a binomial is our next step. So we're going to get 2x log 3 minus 1 log 3, or just minus log 3. Now, everyone who puts your exponent in brackets in front of you remembers to distribute. Most people who do not put the brackets forget to distribute. So make sure you just do the brackets and life is good. So we took our exponent, we dropped it in front, we distributed it. Now, we're trying to solve for x in the end, correct? So what we're going to do here is we're going to move anything with an x to one side, anything without an x to the other side. So I'm going to move this 2x log 3 over with this x and leave this one over here because it doesn't have an x. Okay, that's our next thing. Get the terms with one variable on the same side. So 3x log 5. This is a positive 2x log 3, so I'm going to subtract it. Minus 2x log 3. And then it equals negative log 3. Now, this is one term connected by this term with a minus sign, correct? What can I take out of both of them? An x. I can take an x out, right? So I can take an x out of both of these terms. The x stays out front, and then I'm left behind with 3 log 5 minus 2 log 3 equals negative log 3. I want to get x by itself. X is now multiplied by this beautiful looking bracket dealio here. How do I get rid of this multiplication of this lovely, wonderful log expression? Divide it. For those of you who are like, I'm just never going to know how to do, it will be on the test. Okay? Don't be that person. Learn it, be it, sleep on it, you know, you on with it. This will be there. It will be on your test. It will be. Not like it might be, it will be. Now we just type it into our calculator. Negative log 3 divided by this in brackets. So what's sad is that people get to this point and then they just don't put the denominator in brackets and get it wrong, which is just so sad. So sad. Okay? So you're going to go negative log 3 divided by 3 log 5.
Yeah.
Where is it? Can I use it?
Yeah.
Please?
Yeah.
Thanks.
Yeah.
So negative log 3. Also, you guys, you say this is negative log 3, correct? You don't say this is subtraction log 3, do you? Do not put a subtraction sign here. Okay? If you do, it's not pretty. Now, whenever a log opens up, it opens a bracket. Once again, please close the bracket. If you don't do that, it's going to minus this whole thing from that log. It gets you wrong answer again. So the answer is negative 0.4175, blah, 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 which is negative 0.42. Okay? These ones, if you just practice it, you get good at them. It's literally just algebra, right? This is what usually people really like because it's just same steps over and over and over, and people like steps. So this just makes it that little bit harder, a little bit. This one will be on there too. Okay. Why does this one make it harder? Because when we had this question before and we had that little 2 in front, we could just divide it over, correct? and it went away, and life was good. We converted it to a log, and life was good. So the 2 now is here. I can't divide it over here and say this is a 3. You know how many people do that? A lot. This x plus 1 is attached to the 6. Okay, you can't divide by the 2 because the x plus 1's attached. So you literally have to log both sides, and then you're going to have to use the multiplication rule. Okay, star this one. Go back and do it 8,000 times if you have to. And 8,000 might not be enough, so do it 8,200 times. Okay, learn the steps. So we have 2 bases with 2 separate exponents, and we're asking you to solve it. So what we do is we log both sides. So we're going to log 2. Now this is what I do to remind myself. It's 2 times 3 to the x equals log 6x plus 1. It's 2 times 3 to the x. We agree? Okay. There's one step here that you have to remember to do, and if you don't remember to do it, the whole thing goes completely garbage. Okay? People take this x and they want to drop it in front right now. You can't. Is this x to both of these? No. The x is not to both of these. So I cannot take that x and I cannot drop it in front. Okay? I can't. So what I'm going to have to do is separate these first. From yesterday's lesson, if I have a multiplication in between, how can I separate them? Add them. Add them. So we're going to get log 2 plus log 3 to the x equals log 6 to the x plus 1. This is the extra step compared to if you don't have that extra little 2. This is what makes it that little bit harder. Okay? This is the step that everyone forgets. Last time we took the log both sides, we took the exponents, we dropped them in front. That's just what we could do right away because we didn't have that extra number. But because we have this extra number here, we have to log both sides, separate it with a plus sign first. Okay? Then we can drop our exponents. This is that little extra step that if you don't do it, it's not going to be good. So we get log 2 plus x log 3, because now we can drop our exponent in front, equals x plus 1 log 6. I'm going to put that x plus 1 because it's a binomial. I'm going to put it in brackets so that I make sure that I can distribute. Make sure that I distribute. Okay? So I'm going to distribute that in. I get log 2 plus x log 3 equals x log 6 plus log 6. After I distribute, what do? Get all the x's to one side, anything without an x to the other side, because ultimately I'm trying to solve for x and I'm trying to get the x's out. And the only way I can take a GCF of x's out is if every term on that side has an x, right? That's the only way I can do it. So I'm going to take these x's and I'm going to move them together. So I'm going to subtract the log 2, and I'm going to subtract the x log 6, subtract the log 2 from both sides, and subtract the x log 6 from both sides. Could I have subtracted the x log 3 and subtracted the x log, or subtracted the log 6 and been completely correct? Yeah, it doesn't matter. I just picked one x to move to the other one. Like, don't spend numerous amounts of hours trying to figure out which one's better. Just pick one and move it. So I moved these ones and I moved these. So now I have x log 3 minus x log 6 equals log 6 minus log 2. And now, because I have the x's together, I can pull an x out. And I'm left with log 3 minus log 6. Log 6 minus log 2. And because this is multiplied by x, I can just divide it over. Now, because these have binomials on the top and the bottom, you need to put these in brackets like this, or it won't work for you. I promise you, the people who practice this question and types like this from your textbook over and over and over, it just becomes part of you. You just know what steps to do eventually. The people who practice this once or twice will not get this on the test, because you'll forget a step, or you'll get stuck and be like, oh, I can't remember what to do, or you'll forget this step here. I promise you that's how it works. This question is literally, and the one before is literally just one. You practice over and over and over, and the steps become part of you. Okay? So you're going to get log 6 minus log 2 divided by log 3 minus log 6. X equals negative 1.58. Okay, solving logs. So we solved exponential, and now we're solving logs. These both have base 9. When something is the same base, what's a huge hint? What's probably going to happen? You're going to put them together. So this one has a positive 1 in front. This one has a positive 1 in front. So I'm going to get log base 9. And they're both going to stay on the top because they both have a plus 1. I don't have a denominator at all. So I'm going to get x times 3. So I'm going to get 3x equals 1. So when I have one log and I'm missing the variable here beside the log, or I'm missing the variable here as the base, what do? Convert it to exponential. If you have a single log and you're missing the variable here or the variable beside it, you convert to exponential every single time. That's why these units are together. That's why we only tested you on these units together, not separate, even though they're separate in the textbook, because you need them together. How do we convert from a log to an exponential? 7 rule if you have the log on the left. 9 to the 1 equals 3x. 9 to the 1 equals 3x. 9 to the 1 is 9. So 9 equals 3x. Divide by 3, x equals 3. Okay? You have to check for extraneous roots. What does that mean? This value down here in the log and this value here, they can't be negative. They cannot be negative. So if I put the 3 back in, this is going to be 9 here. I'm fine. It's okay. It works. You can always check them and see if left side equals right side as well, because when you go to type in your calculator, if it's negative, it'll error you and say, nah, can't happen. Okay? So if I go log base 9 of 9, what's 9 to the power of what is 9? 1. So it works. I'm right. Checked it. I'm good. These have base 5s, so I'm going to put them together. They're binomials, so when I put them together, I'm going to get a quadratic. Remember how last year quadratic, you were like, quadratics are so hard. They're everywhere. They're everywhere. They're going to be here. So log base 5. This has a positive 1 in front. This has a positive 1 in front. So I'm going to multiply them. I'm going to get x plus 1 times x minus 3 equals 1. Then I'm going to FOIL that. So I'm going to get log 5 x squared minus 3x plus x minus 3 equals 1. So I get log 5 x squared minus 2x minus 3 equals 1. I don't know the log. I don't know what's beside the log, so I have to convert it to exponential. If the log's on the left, you do a 7. 5 to the exponent 1 equals that lovely trinomial. 5 to the 1 equals x squared minus 2x minus 3, which some people I heard say it's a disgusting trinomial, not a lovely trinomial. Nonetheless, a trinomial. So in grade 11, this was a question. I'd give you 5, because 5 to 1 is just 5. 5 equals x squared minus 2x minus 3, and I told you to solve it. What do you always have to do when you have a quadratic and you're asked to solve it? Move everything to one side and get it equal to 0. So I'm going to get 0 equals x squared minus 2x minus 8. Then what times what equals negative 8. What plus what equals negative 2. Negative 4, positive 2. And because it has a 1 in front, I can just go right to brackets. I don't have to do decomp. X minus 4, x plus 2. And then you have to solve them. X minus 4 equals 0. X equals 4. X plus 2 equals 0. X equals negative 2. What I tell you have to do? Check, 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 check. So I take the 4, I plug it in. 4 plus 1 is 5. We're good. 4 minus 3 is 1. We're good. It's positive. I take the negative 2. Negative 2 plus 1 is negative 1. Go log negative 1 divided by log 5. What's log negative 1 divided by log 5? What does it say when you type it in? Quit. Error. You can't do it. If, when you plug this in, you get a negative beside the log or a negative in the base, it can't happen. This one's out. So the only answer is x equals 4. How can they ask this question on the diploma where you can't go y1, y2? Because I could technically right now give you an answer. I can go type this ugly looking thing into y1, type 1 into y2, second trace 5, enter, 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 and I'm going to get 4. And I'm good. I don't have to know any algebra. Because the moment I have something equals something with one variable, I can y1, y2 the heck out of it and give me my answer. Every single time. Doesn't matter what unit we're in. We can do that. So if you're on the diploma and that's an option, please try it out. How can they ask this and force you to do it algebraically? They can ask you, what's the extraneous root? You can't find a root that doesn't exist on your calculator. It's not going to be like, oh, by the way, the answer is 4, and in your calculator it's not going to write, and the extraneous root is. It doesn't do that, right? So that's how they can force you to do it algebraically, because the extraneous answer, I shouldn't say root, this is extraneous, is negative 2. They can ask you for the extraneous one. They can ask you for the one that doesn't work, forcing you to do it algebraically, right? No, because if they give you any type of negative answer, they all won't work, right? They could say x equals negative 2, negative 3, negative 4, negative 5. Any of them will get you negatives. So you'd actually have to find the exact extraneous root. That's how they can do it. Okay? These ones, I'm going to go to example 2. These are not hard, you guys. And example 3, example 2, and example 3, they're not hard, but we're going to do them on Monday with the word problems, which aren't very long. Okay? So I'm going to give you the homework if you flip a few pages ahead. I'm going to give you the homework that you have to do. I'm also going to hand you out the log hand-in if you want to start. 2 and 7 all. These are only the exponentials. I'm not making you do the logs like we just solved some logs. Those will be assigned on Monday. I want you to do 2 and all of 7. I want you to get how to do those exponentials. You log both sides and you have to distribute, put it over, distribute. I want you to do those really, really well. So I'm only assigning a very little amount of homework. Okay? So do it well. Bye. And you have to make sure to do the stuff from yesterday.